my name's Viridiana Cerda,
I'm Jonathan Hale.
I'm Carly Winters.
I'm Cassie Ma.
and this is our Engineering 6 Sensors project. So for our project, there are various components, one of which is the acceleration data. So when the user uploads the .map file onto the app designer, they're able to display the acceleration data in a table and a graph with the respective X, Y, and Z direction values.
Our other component is the position data. When the user uploads their .map file, the position data will be shown in tables and graphs with the columns date, time, longitude, latitude, altitude, and speed.
After the data is collected, it will save the information on a CSV file, which can be convenient for the user.
And then finally, we have our ThinkSpeak channel. So we created 2 channels, one for the acceleration and one for the position in order to isolate each of the data points.
When you log into the MATLAB mobile app, you can activate the sensors by clicking this button. The sensors available are acceleration, magnetic field, orientation, angular velocity, and position. For this project, we used acceleration and position. In order to collect data, you'll hit start, and then after 10 minutes, we hit stop. And then you save your sensor data as any name, and then you'll be able to access it in the sensor logs tab. And once it saves, if you're connected to Wi-Fi, it will be automatically uploaded to your MATLAB drive.
Now we're going to give the run through on how it works. So first you have to click the Import Sensor Data button, which will then prompt you to choose the .map file that should have been uploaded using the MATLAB mobile app, which records the sensor data. So then it displays that data in 3 different graphs in 2 different tables. You can then display the position data on its own graph to the right using the Display Data button. And then after that, you can create your own CSV file and name it to whatever you want to save it as. Finally, you can use the other features such as extracting position data at whatever date or time you want. So you can put a number between 1 and 614 and it'll extract that line from the position table and display it to the right. And finally, you can click the Calculate Average Speed button to calculate the average speed for all of the position data and display it in meters per second, miles per hour, and kilometers per hour, depending on your preference. And finally, you can click the ThinkSpeak button to display the data in a public ThinkSpeak channel. As you can see, we decided to make 2 different channels for the convenience of the user to have the acceleration and position data separate.
Now we're going to show you our code. This shows that it's a .mat file, and this selects .mat file to open. And these 3 are the plot functions that, and this shows this, like the display, and this is the X and Y coordinate, and this shows the acceleration table, and this shows the position table.
Moving on to the next part, we have the function for the display data button. So the first thing that we do is call the data from the tables. So we call it from the position table, which is table 2. And our X values are the longitude and our Y values are the latitude. And for this, to display the data, we color coded it based on the average speed. So for the color red, it's when they're not moving. And then for the color blue, which is the next else if statement, it describes when you're walking below the average speed. And the yellow displays when you're walking the average speed. And then when you're walking above the average speed, the color is black. Next, we use the scatter function to call the UI axes 4. And then we display the X vowels, the Y vowels, and the color that is represented based on the average speed. And then the color is also filled, and then we hold it on the plot. Moving on to the next section. So we have the function to create the CSV file button. And first we redefine the variables, the acceleration table and the position table. And then in order to create the CSV file, we use the IPut file. And so that the only output that this file can be saved as is a CSV file. And then we made the two write tables, which does the acceleration table and the position table. And then the outer join function combines the two tables and saves it for the CSV. And then the last code write table CSV file name is what finally makes it a CSV file.
All right, moving on to the ThingSpeak part of it. We have two ThingSpeak channels, as you can see. This one is the acceleration ThingSpeak channel, and then this is the position ThingSpeak channel. So for the acceleration, we have the positions X, Y, and Z, which is why we have from 1 to 3. And we have it showing the acceleration like every 100 points, just because ThingSpeak only allows one data point per second. And for acceleration, there's multiple data points in a second, which is why we have it going from 1 to 100. And yeah, that's pretty much it for the acceleration part. And then for the position aspect of it, we had 4 different data points or field names, I guess, for the position, which is why we have from 1 to 4. And the same thing with, I mentioned with acceleration, how ThingSpeak can only handle 1 data point per second, which is why we changed position to 1 to 2, just so we can show every other timestamp to it so that it wouldn't crash. And yeah, that's it for the ThingSpeak part.
I'm going to be explaining the extraction values and the calculating average speed button. So for the extracting position data, you can put whatever number that you would want between 1 and 614, and it will be saved as a value variable. And then that value variable is called in the next line, which would then access that row number for the entire row on the position table, and then displayed on its own table, which is UI table 3. And for calculating the average speed, this calls the entire row on the position table and then calculates the mean, and then this does the conversion to miles per hour, and this one does the conversion to kilometers per hour, and then it's displayed on each row on the 4th table showing average speed.